Hi, my name is Ania, and I am going to talk about getting recommendations out of nothing. A few words about me. I work at 10 Clouds. We build great apps. I'm a muffin provider. I'm also a Python developer, recently working with CoffeeScript and a team leader, but usually people talk to me about muffins, so probably this is my role. I've also done a recommender system for Moto Integrator website. Probably if you would like car parts, if you would like to buy car parts in Poland, you would go to Moto Integrator and you would buy them there. This is the most popular shop in Poland. Also, my master thesis was on conversion rates in e-commerce websites. What I'm going to talk about, when I was creating the topic of a presentation, I thought that a case study would be the best idea to show recommendations. But afterwards, I decided that I may focus mostly on the parts that require most research while creating recommendation systems. So I will tell you something about a bit about the theory of recommendations, about collecting user input while not having a review system, about processing user preferences, and on using recommendations. So, starting from the theory. Recommendations can be reduced to a problem of estimating ratings and preferences for items that haven't been ranked by users, that the user hasn't taken any actions on. So formally, we would have a set of capital C users, capital S would be the set of items, and we would like to get the items that would be highly rated, the most highly rated items. Some examples, we know Amazon, their recommendation system is based on user ratings and on the actions that were made by the users. Of course, Netflix that recommends us movies that we would like to watch. And Goodreads for books. It is worth noting here that Goodreads has divided its recommendations into specific parts about currently reading, to read books, and the read books. So while I am currently reading only software books and programming books, it would recommend this specific type of books for me. And also Spotify. Spotify is the first example here that doesn't have a rating system. It only uses the amount of information that it can get from us while we are listening to music, and also only starring specific songs. And also Facebook, we probably know this. It uses our likes, our tastes to produce recommendations for us. So recommender systems can be divided into three main groups. It would be user-based recommendations, content-based recommendations, and hybrid methods that combine both of these earlier mentioned. Collaborative recommendations are the recommendations that are created for the user basing on other user actions, on other user tastes, similar to the actions and ratings and tastes that the current user has. Collaborative recommendations have its limitations. It's good for small data sets, so if you have less than a few thousand of products, you would probably want to use collaborative recommendations. It tends to be slow for big data sets, and it tends to be really inaccurate for sparse data. It also allows some cold start for new users and new items, but this is probably common to all the recommendation systems. And it's also simpler to implement, and you will see it afterwards. Content-based recommendations, on the other hand, recommend items that are similar to the ones that the user has taken actions on, that the user has rated, and so on. they are more complicated to implement and to test. You have to remember about the additional overhead for similar storage. You have to create the storage. You have to maintain it. So this is the thing that you have to remember about. It's also over-specialized. It could be seen for the book recommendations from Goodreads that I have been recommended books only from programming because I'm currently reading only programming books. And also we have to allow this cold start for new users. Hybrid methods combine both of the methods mentioned earlier. For example, developing a single unifying recommendation model is used in Netflix. Also, the other methods can be combined in many different ways. So our use case, our Motor Integrator website, is a website with car parts. Usually people wouldn't sign up on this website because when you want to buy car parts, you just want to buy them. You don't want to sign up, you don't want to rate the parts, you just want to buy them. So usually you wouldn't also recommend the products, you wouldn't review the products. So it is just a big website with car parts. Our starting point was a big set of items. I think it was 160,000 products at the beginning. We haven't had a review system. Our products were stored in PostgreSQL. We had Redis for session storage and Solr for search as a search engine, and we were using Django. Because we had such a big set of items, we decided to use a content-based recommendation system. We have to start, while building a recommendation system, we have to start with collecting user data. And we have to remember that user ratings are actually the user actions, that everything that the user does on a website. So, for example, our scoring would be defined basically known for no actions with the products, one for the products that were browsed by the user, and two for bought. We could extend the system by giving higher scores to products that were reached via search, or scoring the elements that were added to wishlist. We just have to remember that all the actions that the user has taken have to be stored somewhere and have to be rated, because this is the only information that we got. As I mentioned earlier, we had used Redis to store sessions for the users, so we used Redis also for this for the preferences storage. Also, Redis has some nice features with storing sorted sets and making calculations with the sorted sets that are really fast, and they tend to be much more faster than the calculations that we would make in Python, for example. You would probably want to use Redis or MongoDB or Couch. MongoDB also has some nice features like MapReduce. It would also help probably while using this for recommendation systems. So the basic idea with storing user actions is just saving the ratings for the items that the user has taken actions with. And in Redis, it's quite simple. We just push a specific item to the user keys list. We have defined specific lists for specific types of actions. So it's really simple. We don't need to make anything more. We just take the action that was taken, and we push the item ID to a list. We cut out the old elements. For us, it was 50 elements, but probably on a website that isn't commonly used, and the actions of the user would have to be rated. Well, If you would want to store older items because you know that you don't have enough elements, you would want to define the maximum of elements to be a higher amount. Also, we need to store the user key in a registry of users' keys because it will be used in further calculations. We have to remember that we don't want to lose our data because in such a system where we don't have a review system, the users probably won't be logging in, and in such a website with car parts, probably users won't be logging in. They will want to create purchases without creating accounts and so on. We have to track the user from the very beginning, and afterwards, if he logs in, we would want to merge his session into his user key. We also have to remember about this cold start. We aren't able to do anything with this at the beginning. While we have collected the data, we want to calculate similarities between the users. We start by finding similar users. This is the collaborative filtering, collaborative recommendations system, but we just want to start by it just to understand the whole idea. Similarity score can be defined as can be done by many different ways. It's probably all this boring maths and probabilistics and so on. So the most commonly used will be defined. I will tell you about the most commonly used. It was Euclidean distance, Pearson correlation, and Cousin similarity. The Euclidean distance is basically about finding the users, the items that are most close to the ones that we are analyzing at the moment. So if we would want to, this code probably wouldn't work because it's simplified just to show you what is happening. So we are just taking the actions that the user has taken for two products, and we are checking how distant from each other the products are. This was just a plain overview. It isn't to make you understand and remember it, just to give you some code and show you that, okay, I know what I'm doing. Pearson correlation score is about finding how the users are placed on a straight line. I won't go into any further details. So probably if you want to create a recommendation system, you would have to make a research in that field also. When we know how to rank the users, two users between each other or two items between each other, we can create we can define the top matches for a specific user or a specific item, because finding similar items or finding similar users is basically the same idea, but made in a different manner. So when we know how to get these top matches, it's actually we have these similar items found, and at this point, our CEOs told us, okay, recommendations always suck. You have to do something that they wouldn't suck. So we didn't understand what they meant, and they meant that the recommendations are always slow. So, and all the recommendations that they had been working with were the recommendations created while the site is loading. So while we would be loading a product, the top matches would be retrieved in real time. So this just can't be fast. If your user database is huge, if your item database is huge, it just can't be fast. So we want to make it fast, and we use this top matches method to create a similarities data set. This data set will be calculated at the beginning each day, probably nightly, and it will be stored to give you the recommendations, that the similarities between items while the site is loading, so you don't have to calculate it each time. It's mainly taking user actions, taking the actions that they made on the items, and creating top matches for the items and storing the items with their top matches. So in the end, we have similarity storage, where we have an item ID and a list of items that are similar to that item. When we have this, we can make the recommendations. Some use cases would be recommending items to users. This is the most common case. Recommending items similar to a specific item. For example, if you are in a cart, you would take the cart items and create and define items that are similar to the ones that are in the cart, and you can make it fast. Also, we can find users that would likely be interested in certain items. For example, if you, if you have sellout, or you create an outlet or something like this. So this code probably wouldn't work also. It lacks all the checking and error validation and so on. It's just to give a basic idea of how the item recommendations are made. We just take the items that are similar to a specific item from the similarity storage. We take the items that are similar and we return them. If this is one item, we just take the elements that are in the similarity storage. And if there are more items, we would use this nice Redis feature, zunion store, that would take all the item keys and calculate the rankings for the items. So this probably would take more time in Python. It's really fast in Redis, and it doesn't stress Redis a bit. For user recommendations, it's basically the same. We just want to have the weighted scores basing on the elements that the user has taken actions on. The items that we have also have to be squeezed. This is the part where Solar is coming in. After we have these similarities and recommendations from our similarity storage, we would want to apply some boosters. For example, if we know that the user has liked a lot a specific category of breaks, we would want to recommend breaks higher than the other elements. Also with the item connections or item alternatives, if you know that a specific item is an alternative to the one that the user has already viewed, you would probably want to show it to the users. Also the keywords. Testing such a system is about stress testing. So you would probably create a dummy database with 1 million items and 100,000 sessions and so on. And for us, it was calculating similarities for such an amount of data was 2 hours. So it's really fast. You would want to create effectiveness tests also. This is also mainly math, and also conversion rate tests that would tell you if your recommendations actually work for the users. Some conclusions. Content-based recommendations are good for big set of items. For this problem, a collaborative system wouldn't be enough. Redis is pretty nice for all these calculations and for storing user database with the similarities. And you have to remember that getting all the available data for such a system is really important. because this is probably a starting point for some of you that don't know anything about recommendations, these are some references to start programming a recommendation system. Programming Collective Intelligence is a book that is really awesome, and probably after one weekend with this book, you would create a really nice recommendation system. And okay, that's it. Maybe questions?